Great seeing you here again. My name is Luc de Kuster, founder of the Kuster Academy, and welcome back to a new video of the Math Survival Guide. In this new video, we're talking about the equation of a line perpendicular to another line. And that line, that perpendicular line, has to pass through a specific point. We will be starting from the point-slope expression of a line. But before we continue, don't forget to click on the subscribe button, click on the bell button, and every time we have a new video, YouTube will inform you about it. So let's have a look at the perpendicular lines, and I want to remind you what it means. When we have two lines, two different equations of a straight line in their point-slope expression, for example, y is m1x plus k1, and y is m2x plus k2. Those are two different lines in their point-slope expression. And we can say that those two lines are perpendicular to each other when the product of their slopes is equal to -1. And that's the property we're going to use once we have the equation of one line to find the equation of the perpendicular line. Let's have a look at the elements. What is very important to understand here? When we look at the perpendicular line, we base or we find the slope of the perpendicular line. But we will see that there are multiple perpendicular lines possible. So when we look at a typical line, classical line, y is m1x plus k1, and we can draw that line in the x and y coordinate system. Then we can say the perpendicular line is in fact given by y is m2x plus ki, m2 is m based on m1 times m2 is -1, and ki means that we have different possibilities, lines which are all perpendicular, but they all have a different y-intercept. And this is the element that I want to show here, is that we have a possibility of a multitude of perpendicular lines. The way to find one specific line can only be done by defining the y-intercept or a specific point through which the line has to pass through. Let's have a look how we can find the perpendicular line through a specific point x1, y1. We have the same equation, y is m1x plus k1, and we find the perpendicular line when we have, let's say, the equation y is m2x plus k2. We know that the product of the two slopes is equal to -1, and we can replace this in the equation. And now we have to find the y-intercept when the perpendicular line passes through a specific point. So what we can do here is to rewrite the equation. We can say y is -1 divided by mx plus k2, because we know that since both lines are perpendicular, the product of the slopes is equal to -1. So the slope of the perpendicular line is equal to -1 divided by m1. And now we have to find the k values. So we have to replace x and y by their values. And then we find that k, the y-intercept, is y1 plus 1 divided by m1 multiplied by x1. Let's do this in an exercise. We have the same elements. We have the same type of equation. Y is 1/3 x plus 2. So we have a slope which is equal to 1/3 and the y-intercept which is equal to 2. When we look at the slope and we have the y-intercept, we can in fact draw this line in the x and y plane. So we find the y-intercept, we have the rise and the run that we have, and we can in fact draw the line using the slope that we have defined. So that's the first element, and we see that this line, the green line, has the equation y is x divided by 3 plus 2. The next thing what we have to find is the slope of the perpendicular line, and we know that the product of the slopes is equal to -1, which means that m2 is equal to -1 divided by m1, which in this case is equal to -3. So it's logical when the original line has a positive slope, the perpendicular line will have a negative slope. That's something that you have to keep in mind when you're doing a calculation. These are things that have to be obvious to you. So when your calculation would be wrong, you will say there is something wrong. And when you would find, for example, that m2 is equal to 3, it's not possible because we know since m1 is positive, m2 has to be negative. We can put this in the equation. So y is -3x plus k. So that's the equation of the perpendicular line. We put it through a point 4 and 7 halves. And now we can replace, we can draw the line, and we can calculate its equation. It means we can calculate the value of the y-intercept. And we find it through this point. So when we look at the solution here, we have the equation y is x divided by 3 plus 2, which is the original equation. We have the perpendicular line, which is y is equal to -3x plus k. And we can replace the x and the y by the coordinates of the point, 4 and 7 halves. So we see that 7 halves is equal to -3 times 4 plus k. And when we bring k to the left-hand side and all the other elements to the right-hand side, we can see that k is equal to 7 halves plus 3 times 4, which is in fact equal to 31 halves, 31 divided by 2. The equation of the perpendicular line through the point 4, 7 halves is given by y is -3x plus 31 divided by 2. What we can do now is to find the standard form of the equation of the line. So first thing what we do in this case, we bring x and y to the same side, to the left-hand side. We don't have to multiply here because we already have -3x, so we just bring -3x to the left-hand side, which gives us 3x plus y, and at the right-hand side we still have 31 halves, which in this case is c. That's the element of the equation. We can multiply by 2 to remove the value, the denominator, and it makes the equation a little bit nicer. We don't have any fractions. So we find basically the end result is 6x plus 2y is equal to 31. So that was the way how to calculate the equation of a perpendicular line through a specific point. And we've seen all the different steps, and finally we found the standard equation of the perpendicular line. That's it for this video. Don't forget to click on the subscribe button, click on the bell button, and every time we have a new video, YouTube will inform you about it. Thank you very much, and I'm looking forward to seeing you in our next videos. Bye bye.